Okay then gang, so as we start to write more complex programs, there's going to be points in our code that we need to either make some kind of decision on what to do next, or maybe execute a piece of code over and over and over. We want to somehow control the flow of our code. For example, if we have an array of data, for example, this array of names right here, that we want to maybe cycle through and perform some code on each element inside that array, then we would use what's known as a loop. A loop is a type of control flow in JavaScript, okay? Likewise, at some point, we might also want to check if a certain condition is met. For example, is a user logged in, or is a score over 100? And then only run some code when that condition is true. And this is known as a conditional statement. So these two different concepts of looping and conditionals, they are collectively known as control flow in JavaScript because we're using them to control the flow of our code or application, whether that be using a loop to repeat a section of code or to conditionally run a section of code based on a certain condition. They're really important parts of the language, and we're going to be using variations of them quite a lot as we go through the course and make different projects. So we'll be talking about these concepts and looking at the different kinds of loops and conditionals for the rest of this chapter. Okay then my friends, so the first type of control flow that I want to talk about are loops. And in particular, we're going to talk about one type of loop. Now there's many different types of loops in JavaScript. I do think it best that we just focus on one of these, a for loop, to begin with, then we'll talk about the rest of them later on. So I'm going to write out this for loop first of all. Then, after I've written the loop, I'm going to explain it and show you how it works. So, I'm saying let I equal 0, then a semicolon, then I is less than 5, semicolon, then I plus plus, then we open and close some curly braces like that at the end. Now, we don't add a semicolon at the end of these curly braces. We don't do that for loops, all right? Now remember, at the end of the day, the job of a loop is to loop through a portion of code over and over and over a set number of times. That's what they're there to do. So keep that in mind when we go through this. So first of all, this thing here, when we open the curly braces and we close the curly braces, that is what is known as a code block. It's just a section of code that we're kind of sectioning off, and it's for this loop, okay? Now then, we create the for loop by first of all saying the for keyword. Then we have some parentheses, and inside the parentheses, we have three different things. The first thing right here, this is an initialization variable. So we're saying to begin with, we're going to create this variable I and set it equal to 0. Now this variable is a bit like a counter, and it keeps track of how many times we cycle through the loop and how many times we run the code inside the loop. Then the second thing is a condition. This is going to evaluate to either true or false. If this condition is true, then we're going to execute the code that's inside this code block. If it's false, then we're not going to. The third thing over here, this is a final expression, and this is going to execute every time at the end of the code block. Okay, so every time we loop through some code, at the end, we're going to take I and add 1 to it. So let's run through this. The code reaches the for loop, and we set I equal to 0 to begin with. Then we check this condition, is I less than 5? Well, yes it is, because it's currently 0. So then we execute some kind of code that's inside this code block. We've not got any there yet, but later we will. Then once we've executed that code, we come up to this final expression, we take I, which is currently 0, and we add 1 to it. So now that's saying, okay, we've been through here once, essentially. So we come back up to the top. We don't reinitialize the variable, we just keep I as 1 because we've just added 1 to it, and we recheck the condition. Is I still less than 5? Well, it's 1, so yes, it still is less than 5. So we execute the code block again, and at the end, we do this final expression, we add 1 to I, and now it becomes 2. Then we go back to the top. Is 2 less than 5? Yes, it is. So we do the code block, and it loops and loops and loops until eventually I is 5. It's no longer less than 5, so then we don't execute the code inside the code block anymore. We've already looped through it enough times based on this condition, so we don't do it again. Then once we've done it, we come out of the loop and we carry on down the file with the rest of the code, okay? So then, let's see this in action. I'm going to say inside here, console.log, and we're going to say in loop colon, and then we'll also log a second thing to the console, which is I. So remember, I is 0 to begin with. Then every time we go through the loop, it's going to add 1 to I. So we should see 0 to 4. We won't see 5 because at the point when I is 5, it's not less than 5 anymore and it doesn't execute the code in here anymore. At the end of it, I'm also going to do another console log and I'll say loop finished. So this is only going to run once we've looped through this X amount of times. So save it and preview over here. And we can see in loop 0, 1, 2, 3, 4. Then we break out of the loop because I is not less than 5 anymore. And finally, we log this to the console. So I hope that makes sense. Now, a lot of the times, we might not know how many times we want to loop through something. We're not just going to pluck a number from thin air and say, okay, I want to loop through you 10 times. No, we don't do that. Typically, what we do is loop through data of some kind. So we could get, for example, a list of users or names from a database. We don't know how many people are in that list or array of names, and we want to cycle through them. And we want to perform a for loop, for example, for each name in that array and do something with that name. So let me comment this junk out and come down here. And what we're going to do is create a constant. Now, we're not going to grab these names from a database because we've not touched that yet. But what we will do is just create an array and imagine that we've got these from a database, okay? So the first name is going to be Sean. Then I'll say Mario and then Luigi. Okay, so now we have our array of names and we need to give this const a name, so we'll call it names. And now I'd like to cycle through this array using a for loop. Okay, now remember I said we might not know how many elements are inside here. We know it because we can just look at it and say, well, there's 3 inside there. So we know how many times we want to cycle through it. But just suspend disbelief for a minute and imagine we got this from a database and you don't know how many names are inside here. We need another way to tackle this. So the way we do it is by saying for, first of all, we still initialize a variable to be 0 to begin with. That's our counter. Then we say for I less than names dot length. So that's going to take the length of this, which is 3, and it's going to say for as long as I is less than that value, then we're going to cycle through it. And that ensures that we're going to cycle through each one. Does that make sense? Cool. So finally, we take I and we plus to add 1 at the end of every loop. Okay, so inside here, I'm just going to console.log I to begin with. Now we should know what happens here. It's going to be 0, then 1, then 2, and then that's it. Okay? Because when it gets to 3, the length is 3, and it's no longer less than that. So then, I don't just want to log out I now. I want to log out the name that we cycle over each time. Okay? So first Sean, then Mario, then Luigi. How do I do that? Because this is not automatically linked to this. All we're doing is using the length property at the minute. What we want to do is every time we go through this loop, log out the names in order. So what we could do is we could take the names and we could use square bracket notation to get each element. And what I'm going to pass in here is I. Now I to begin with on the first loop is going to be 0 because that's what we initialize it to be. So when we first execute this code, I is 0 and it's going to log out Sean. Then we add 1 to I and come back to the top. When we run this code block again, I will now be 1, so we'll get this element and log that to the console and so forth. So if we save this now and preview, we can see all of these names. So that's cool, right? We can now cycle through an array of any length. We don't have to know that length using this kind of syntax. Now imagine instead of just logging this to the console, we wanted to do something like create a little snippet of HTML, a little template for each name, so that eventually we're going to output that to the browser. Well, we could do something like this. Let HTML equal to a template string, which is backticks, remember, and inside that template string, we could just write some HTML. I'll do a div tag and close that off. Then what we want to do is output the variable, this thing, names I, inside this div each time. So remember, to output a variable inside a template string, we use $, then the variable name inside the curly braces, and we want names and then I. So that's going to be Sean first, then Mario, then Luigi. Okay? So then let's log to the console the HTML each time around. So save that view in a browser, and we can see we have a little template now for each individual name. Awesome. So then one more thing before we close up, just a little bit of terminology. You might hear me and other developers in the future talk about cycling through an array or some data as iteration. And each iteration is one cycle through. So every time we perform a code block, that is one iteration through the data. Okay, so that was just a bit of terminology. That is all. We're just cycling through the data. It's the same thing. So my friends, that is a for loop. In the next video, I'm going to shift our focus to another type of loop called a while loop, which is similar, but just a bit of different syntax. Okay then, so in the last video, we saw how to create a for loop. Now in this video, I want to talk about a different type of loop called a while loop. Now they do exactly the same thing. They loop through some code a certain amount of times. There's no real difference. The only difference is the syntax, how we write them. So this was our for loop from the last video. We had three things inside here: an initialization, then we had a condition, then we had a final expression where we incremented I each time around. So if we run this, we should see I go up to 4 from 0, and we do. So what we're going to do is change this into a while loop. So first of all, we change for into while. Then we don't have all three of these different statements inside the parentheses. We only have one of these statements inside the parentheses, and that is the condition itself. So right here we're saying while I is less than 5, I want you to run this code inside the code block. Now there's a couple of problems with this. First problem is that we don't even know what I is. Nowhere in this file do we initialize I. Before, when we used a for loop, we did it inside the parentheses. But we don't do that in a while loop. I must already exist somewhere. So we say let I equal to 0 before the actual loop begins. We declare that outside of the loop. Now I'm not going to run this because if I do, it's going to be a big problem. We're going to get stuck in what's known as an infinite loop. So why is it an infinite loop? Well, think about it. We're saying that I is equal to 0 to begin with. Then we're coming to this loop and we say while I is less than 5, then execute this code. Well, it is less than 5, it's 0, so it does this code. Then we're not incrementing I anyway, we're not adding 1, so it's just going to come up again and say is I less than 5? Well, yeah, it's still 0, so we're going to run it again, and over, and over, and over, and over, until eventually your browser will probably crash because we're outputting it so many times because I is never changing. That is an infinite loop, and it's a really bad thing. So what we need to do before we run this is find a way to increment I every time around. Now before, when we used a for loop, we did that inside the parentheses, but again, we don't do it here in a while loop. We do it inside the code block. So we could do it at the very end right here. So we run the code, and then at the end of the code block, we say take I and add 1 to it. Then when it comes to the top again, it's going to say, well, I is 1 now, it's still less than 5, but eventually I will get to 5 and then it won't run. So we're not caught in an infinite loop, okay? So if I save this again, I'm going to go over to the browser and now we can see exactly the same result. So this works. So this is just a different way of creating a loop using a while loop instead of a for loop, okay? So before we did an example with some data, some names. So what I'm going to do is also create a constant here called names and set those equal to an array. We'll put inside Sean, Mario, and Luigi. Okay, so we have those names and we want to do the same thing now. I'm going to comment this stuff out. I want to cycle through those names using a while loop. So what I'm going to do is again say let I equal to 0. We still need that initialization variable. Then I'm going to say while I is less than names.length. I want to do something. And inside here, what do I want to do? I just want to log out the name. So I'll say console.log and then in parentheses, the names, and then we'll pass I in square brackets to get that position from the names array. Now we need a way to increment I, otherwise we're going to get stuck in an infinite loop. So we'll say I plus plus at the end. And this is going to do the same thing as the for loop before. It's going to cycle through these and it's going to output the name each time around. So save it, preview, and boom, we get those names, okay? So there we go, that is a while loop, just an alternative to a for loop. So then, just a quick video about do while loops, which is really just an extension of the while loop up here. So we've seen that we can do a while loop where we evaluate some kind of condition, and if that is true, we run the code, and then we add one to whatever the counter is. Now imagine that we start off with I equal to 5, then this thing right here, this is never going to be true, and we're never going to run this code. Now that might be fine, but sometimes you want the code to run at least once, even if this condition is not true, okay? So even if I starts at 5, it would be nice to maybe run the code once and then we don't execute the loop anymore, okay? Because the condition is not true. So how do we do that? Well, we'd use a do while loop, which, like I said, is just an extension of the while loop. We just write it a bit different. So I'm going to take all this code here, the code block, and cut it, and then above while I'm going to say do, and then I'm going to paste the code block. And now what we're saying right here is do this code, and it's going to do it once to begin with, regardless of the condition being true or false in here. And then at the end of the do block, we have our while keyword, and then we do add a semicolon at the end because it's not a code block at the end anymore. We don't add them when it's a code block at the end, but now it's the while statement, we do add our semicolon. So again, we're saying let I equal 5, then we come down here, we do this code block regardless, and we still add 1 to I, then we run the while condition. And if I is less than 5 again, then we go back up to the loop and run it again, and we carry on as normal. But all this does is run it once to begin with, even if the condition is not true in here. So let me save this and preview in a browser, and we can see the val of I is 5. So that is because we run this once and I is 5. If we change this to 4, then save it, it's still only going to run once because we run it and I is 4, then we add 1 to 4, which is 5, then we evaluate the condition. Well, I is 5 now, so it's not less than 5, so we don't run it again. If I is 3, then we should get it twice. We get 3 and 4, okay? So that's an easy way to execute a block of code inside a loop first, regardless of whether the condition is true or false. Okay then, so we've seen how we can use loops to execute a block of code a certain number of times based on a certain condition. Now the other type of control flow is conditional statements, also known as if statements. And they're called if statements because we say if a certain condition is true, then we do something. So we check a condition and we only execute a code block if that condition is true. Now this time we don't use any kind of counter variables because we only ever execute the code block once or not at all. We don't loop over the same code multiple times like we did in loops. So let's do an example. I'm going to create a const called age and set that to be 20 to begin with. Now I'm going to do a conditional check, an if statement. And to do that we say if, then in parentheses we do our condition. What do we want to evaluate? Well, we want to say if the age is over 20, then we have a code block at the end where we want to do something inside. And this code block is only going to execute if this condition is true. So inside here, we'll just say console.log and then you are over 20 years old. Okay, so if we save this and preview it in the browser, then we don't see anything. And we don't see anything because this is not true. Age is not over 20, age is equal to 20. So if I change age now to 25, then this should evaluate to be true. And now we can see you are over 20 years old, okay? So that there is an if statement. Now we can also do if statements with data, so to check if we have certain amount of items in an array or something like that. So I'll create a new constant and I'm going to call this ninjas and set this equal to an array, and inside I'll do a few different strings. So we have Sean, and then we can have Ryu, then Chun-Li, and then finally Yoshi. So we have 4 names in there. Now what I want to do is say if ninjas.length is over 3, then we'll execute some code. So it's going to grab the length of this, which is 4. Is it over 3? Well, yes it is. Therefore, this evaluates to true and we can execute this code. So inside, we're just going to log a message And this time I'm going to use double quotes, and I'll tell you why in a second. I'm just going to say that's a lot of ninjas. Now, normally when I do strings, I use single quotes, but I did double quotes because there's a single quote inside the string right there. So if I used a single quote to do the entire string, then you'll notice that the string is actually closed here. So it's no longer used as an apostrophe, but to close the string instead. We don't want that. We want to use double quotes so that this single quote here does not close the string, okay? So anyway, let's save that and run it, and we should see that in the console. Now, if I change this to be something like 4, then the length is not greater than 4, and we don't see that statement. So these are, I suppose, silly examples of why we'd use an if statement. Maybe we'd do something like this to check the length of some data, but typically we want to do something more useful, like we want to check if a user is logged in. If they are, we do something. Or if they're signing up, is the password that they provided us with 8 characters long? Because if it's not, we want to send back an error and say, improve your password or something like that. So what I'm going to do now is a very simple example, const password, and set it equal to a string. And the password that a user types in is going to be pass. Now, that's a weak password. So what we're going to do is check if that password they enter is at least 8 characters long. So I'm going to say if password.length, and we can do this on strings, remember, to get back the length of the string. And we're going to say if that is greater to or equal 8 characters long, then we're going to log something to the console inside. We'll say that password is long enough. If it's not at least 8 characters long, then it's not going to run this code. So if we save it, we can see it's not run this code. But if I change this now to something like password, like this, we can see this is now 8 characters long, and this should run. So if I save it, preview, we can see that password is long enough. Now, sometimes we might want to feed back some information if this code doesn't execute. For example, if it was this again and it was just 4 characters long and we saved it, we don't get any feedback whatsoever. It might be that we want to say that password is not long enough. And to do that, we're going to have to talk about else statements. So we'll do that in the next lecture. So then, gang, currently we're checking if a password is at least 8 characters long. Now, if it is, then it's going to run this code block and output this. If it's not, if this is false, for example, if this is 4, 5, 6, or 7, or something like that, characters long, then it doesn't run this code block. Now, it would be good to run a different code block if that condition right here is not met, so we can offer some feedback to the user. Something like the password is not long enough. Now, to do that, we use an else statement. So at the end of the first code block, after the if check, we can say else, then open up a new code block and fire this if that first condition is not true. So it checks this. If it's true, it fires this code block and not this. If it's not true, then it doesn't fire this code block, but it does fire this instead. This is the else clause, okay? So what we could say is console.log and then say password is not long enough. All right, so save that, and since this is currently 4 characters long, it should be the else code block that fires and not this one. So let's check that over here. Password is not long enough. And notice it's only ever going to run either one of these code blocks, either this or this, never both of them. Okay, if this is true, it only runs this and it ignores the else case. If this is false, it only runs this and ignores this case. Now, sometimes we might want to check multiple different conditions. So say, for example, we still want to check the password, but we want to check, first of all, is the password at least 12 characters long? If it is, then we'll output a message that says this password is super strong or mighty strong or something like that. If it's not, then we'll do another check. Is the password at least 8 characters long? If it is, we'll output this. If it's not, then we'll catch it right here and run the else statement. So again, only one code block will ever run, but this time we're going to check multiple different conditions. So how do we do that? Well, let's start at the top. We're going to check, first of all, if the password.length is greater than or equal to 12 characters long. If this is the case, then we're going to console.log that password is mighty strong. Okay, so that's the first condition. Now we also want to check the second condition, but we only want to check this if this is false. So we can't just leave it here, because if it's 12 characters long currently, then it's going to run this and output this, then it's going to come down here and it's going to run this as well. We don't want that, we want one or the other. So instead of creating a new if case, we instead bring this back up and do else if, okay? So we say if this is true, run this. If it's not, then go down to the next clause, else if, and another condition. If this is true, we run this. If it's not true, we go to the else clause and we run this instead. So again, it's only ever running one of them. And we can chain as many of these else ifs on as we want. We could have another if we want. We could do else if here and then else if again. We're not going to do that because it's just going to get messy. But the idea is there. We can chain them together if we want to. So let's run this. I'm going to change this to something like password 1234, which is 12 characters long. So hopefully we get this right here. So save it, preview, and we see that. That password is might strong, should be mighty. Okay. And if we change this back to 8, then the first condition should fail. This should be false, but this should be true. So save it, and we can see that password is long enough. If we change it to 4, then it's going to go right down to the else clause and just run this. Password is not long enough. All right. So there we go. That's how we use else statements and also else if statements to check multiple different conditions. Now then, so far we've looked at several different examples of satisfying conditions and running code if that condition is satisfied. Now, what if we want to satisfy a combination of different conditions all at once in one set of brackets? Because at the minute we're just looking at one condition, is the password length over X amount of characters. If we want to satisfy a combination of different conditions inside the same check, then we can use what's known as logical operators. And two of the main types are logical OR, which looks like 2 pipes, and logical AND, which looks like 2 ampersands. So let's think about this. Imagine we want only this to run if the password length is at least 12 characters, but also includes an @ symbol. So what we do is we place our logical AND, because we're checking 2 conditions. We want both of them to be true. We want the password length to be at least 12, and we also want it to include the @ symbol. So we're going to say AND, using logical AND, password dot includes. We've seen this method before. This is the way we can check if something includes a certain character, and we're looking for the @ symbol. So then, it's checking both of these conditions at the same time. If both of them are true, if it's at least 12 and includes this, then the whole thing will evaluate to true and this will fire. If one of them is not true, so say for example, it is at least 12, but it doesn't include this, then the whole thing will fail. It will be false and it won't fire. They both need to be true for this to work, for this to be satisfied, this condition. Okay, so let me change this to something that's 12 characters long, 1, 2, 3, 4, and it includes this. In fact, we'll take that off for now and just do this. Save it, and we can see that password is long enough. So even though it's 12 characters, it doesn't include this. So this is not true, and it goes to the next else if. Well, the password is at least 8 characters, so it runs this. So then, if we now place in the @ sign, then it should pass this first check, because now both are true. If we save it, and we can see that password is mighty strong. Okay, cool. So that's using the logical AND operator, which is double ampersand. That's how we check 2 different conditions. And you could add a third one if you wanted to, although that would get a bit messy. Now then, let's have a look at OR. So say for this second if check down here, we want to say, we'll fire this code block if the password length is at least 8, or, and it's double pipe, and the pipes are next to the space bar on most keyboards. You probably have to press Shift and that key. So we're saying if password length is at least 8 characters, or if the password dot includes the @ symbol, then we're going to fire this code block. So even if this is 4 characters long, so it's not at least 8, then because we've said or, only one of these conditions has to be true, and because it includes the @ symbol over here, and this is true, then this is fired, okay? So if we save it and preview, we can see that password is long enough. Maybe this should be changed to strong enough, and this should be strong. Okay, so when we use the or operator, only one of the conditions has to be true. So we could change this to be password, and it's 8 characters long, but it's not this. This is false, but this is true. This will still pass because we're using or, and only one of them has to be true. And we can see that password is strong enough. Now, if we wanted to, we could get really ambitious and try something like this. We could chain on an and over here and say password.length is over 5. Okay, so what we're doing here is this is one condition and this is one condition because we've got an or in between them. But this one condition over here is comprised of 2 different conditions, and both of those have to be true for this side of the or to work or to pass, right? So if it includes an @ symbol and it's at least 5 characters in length, then this side will pass. So if we change this back to 4 and we put an @ symbol, and we need to change this right here to greater than or equal to, if we save that now, then it's not going to pass because it's not at least 5 characters long. It has the @ symbol, but this one doesn't pass. If we change it to 1, 2, for example, then save it, then it does pass, okay? So there we go. That is the logical or, double pipe, and the logical and we can add these into our if checks to check a combination of different conditions. Okay then, so far we've looked at a few different conditions and we've executed code only if those conditions are true. But sometimes we want to execute code only if a condition is false. So normally when we do an if check, we do if then some condition right here, and we run the code block if that condition is true. That's the way an if statement works. If whatever is inside here, when it's evaluated, is true, then this code block is going to run. Okay, now imagine we have a user variable, and when it's false, it means they're not logged in. Now I want to make an if check, which is going to run some code, the code block, only when the user is false. Now I can't put in here if user like that and then run some code, because this is only going to run when user is true, and I want it to run when user is false. So how do I do that? Well, to get around it, we use what's known as the logical not, which looks like an exclamation mark. So when we place an exclamation mark in front of a Boolean, so something that's either true or something that's false, what it does is reverse that Boolean. So if I put it in front of a true value, then it's going to evaluate to false. If I put it in front of a false value, it's going to evaluate to true. So let me demo this. I'm going to console.log, and we're going to console.log true, and we'll duplicate this and console.log false. Okay, now then, if I run this, we see true and false. Now what happens if I place exclamation mark and exclamation mark in front of them? Well, like I said, this is logical not, and if it's placed in front of true, it takes that value and it turns it on its head. It makes it false. Same for this. It takes the false value and switches it to true. Okay, so if I save it, we should see false first, then true. And that's what we see, false, then true. So that's how we switch a Boolean value. So now let's go back to the problem. I want this to run if the user is false. Now normal behavior means that the if statement only runs the code block if whatever is evaluated in here is true. Now currently it's false, but if I place the logical not or the exclamation mark in front of it, then it's going to switch that to true. It's going to evaluate as true the whole statement. Bear in mind, this doesn't actually change the value of user. User will still always be false. We're just changing the evaluation here. We're switching what user is inside these brackets, the outcome of the expression. So now this whole thing is going to evaluate to true because this is switching the false value. So now we can say something like console.log, and inside that, you must be logged in to continue, and save it. And if we run this now, we can see this in the console. And that's worked because this thing right here, this exclamation mark, is switching the value of false into true. Alright then gang, so we've explored a lot of different ways to control the flow of our code, loops and then conditionals. Now, I briefly want to jump back to loops to explain a couple of keywords in JavaScript, and those are break and continue. So imagine we have an array of scores, which we do have right here, and we want to loop through them. So that's why I've created a for loop. I'm saying for, then initializing our counter variable to 0. While I is less than the length of scores, we're going to continue, and then each time around we're incrementing I by 1. So inside this loop, all we're doing is logging out the score for each iteration using scores and then passing in the counter variable which starts at 0. So here, then 1, then 2, then 3, etc. So if we save and preview, then it's going to look something like this, and it logs all the scores out. Now then, what are break and continue? Well, let's imagine if we get to a score of 100 when we're going through this loop. When we get to that, that is the max score you can get in this game. And at that point, we want to break out the loop because the rest of the scores after 100, they don't really mean anything because we've already reached the top score. So what we'd do is we'd come down here and we'll say if and scores and then square bracket notation I, so the current score we're iterating over, if that is equal to 100, so triple equals to 100, then we want to break out of the loop. Before we do that, let's log a little message to the console. We'll say, congrats, you got the top score. And then what we're going to do is break out of the loop. So that basically means if we break out of the loop, we're not going to carry on iterating over the last two elements. Even though I might still be less than the score's length, this break keyword means now I just want to break completely from the loop, ignore all this stuff at the top, and carry on with the rest of the code down here. So we're not going to see these two now logged to the console like we did before. So let me save it and preview this in a browser. And you see when we get to 100, we get this message. Then we break out of the loop and we don't do any more. There's no more iterations. So that's what the break keyword does. It breaks us out of the loop. So what about continue? Well, let's do another example. Say instead of 100, we now check for a score of 0. Now, that's a pretty embarrassing score if you get 0, and we don't necessarily want to log that to the console because it's so embarrassing. So what we could do instead is say, okay, well, I want to check if the current score that we're iterating over, so scores and then I, if that is equal to 0, then what I'm going to do is use the continue keyword. And what that means is, okay, I want you to now ignore the rest of the code inside the code block for this loop, but I still want you to continue with the loop itself. So I want you to go back up to the top and go to the next iteration, increase I by 1 and go to the next iteration. So when the score is 0, it's going to run this, it's going to hit continue, ignore all of this code so we don't log it to the console and we don't need to perform this if check either, but we go back up to the loop and we go to the next number, the next iteration, because I is now increased by 1. So that's what the continue does. Jumps out of that one particular loop, that one iteration, and goes back to the top. So if we save this now, we shouldn't see 0 logged to the console after 25, we should just see 30. So save it, go back to the console, and we get 25, then 30, then 100. Okay, so there we go, my friends. That is break, to break out of the loop completely, and continue just to break out of the current loop and go back up to the top and continue with the next iteration. So then, one last control flow technique to look at, and that is switch statements. So imagine we have a value. I've called this value grade, and that is some kind of test grade. And it could be many different values. It could be A, B, C, D, E, F, etc. Now I've given it D, but it could have been any one of those values. Now imagine that we want to check what that grade was and output a different message to the user dependent on the grade. So we could potentially use an else if statement like this for each different grade and then output something different in each code block. Now that's fine, but it gets a bit tiresome writing these conditions out over and over again, and it starts to look a bit untidy as well. Now, a better way to do this, where we're checking multiple possible values of a single variable, is to use a switch statement. And we do this by typing, first of all, switch. Then inside, we do our variable which we're evaluating, that's grade, and then we open up our code blocks. Now, before we carry on, let me just delete all this because we don't need that anymore. So now we're checking the value of this variable. Now, we're going to have several different cases, what it could be. It could be an A, it could be a B, it could be an F, an E. So we want to check all of the different cases that it could be. And we do that by using the case keyword, then whatever that case could be. So in the case that it could be A, we say the case A, and then we do a colon. Then underneath, we indent for readability, and we write the code that we want to run if grade is A. So I could say something like console.log and then say you got an A. Okay? So what I'm going to do is just grab this and I'm going to paste it down here a few different times. Let me just scoot that back over. Copy. Let me just paste these in and then I'll make the formatting better. So case, and case. Now we want to check the case is B the second time, then C, then D, then E, and then at the end we do a default case by typing in default, and then we'll say console.log and we'll just say not invalid grade. Okay, so what's happening? Well, we're checking this variable and we have all of these different cases that it could be. Now, if grade is A, it's going to run this code. If grade is B, it's going to run this code instead. If it's C, this code, etc. Now, we just need to update these messages that we log to the console. So let's do B, C, C, and then D and E. So now then, if we run this, what's going to happen? Well, hopefully, it will see that the grade is D. It skips this and this and this. Then it gets to this, it says, okay, well, grade is D, so I'm going to run this code. So if we save that and preview, then we can see you got a D, you got an E, and not a valid grade. So it's running this, but it's also running this and this. Now, if we change this to A and save, then notice it runs A and everything after it. So why is it doing that? Well, as soon as it gets to a case that it matches, for example, C, then it's going to run the code, but it's also going to run the code in every case after that as well. Now, in order to combat this, in each case, at the end of it, we need to do the break keyword. And what that does is run only the code for that case, and then it breaks out of the switch statement. So let's add this in all of them, and down here as well. And then finally here. Now, in the default case, we don't need to use the break because that is the last one. And the default case runs only when this is something that's not covered in any of these cases. For example, if this was, I don't know, P or something like that. So save it, now run it, and we see we only get the code inside the case for C. Now, if we change this to something like P, we're just going to get the end default case right here. So let's save it and preview, not a valid grade. So there we go, that is a switch statement. And these are good for evaluating a variable which could be several different values if you want to react differently in each case. Just one thing to note, switch statements use strict equality to check. So for example, if I type in 50, for example, if it was out of 100 this grade, and we used numbers like this, then that is not going to work. So if I save this now and come over here, we see not a valid grade because it's using strict equality. And remember that is triple equals, and it takes into consideration the type as well as the actual value. So this would have to be a string to match. So save, and now we can see it. Okay then, my friends, so throughout this chapter we've looked at a lot of different control flow techniques, and in each one of those different techniques we've seen code blocks like this, curly braces, and those code blocks are just little sections of code that run when something is true or some condition is met, right? So now we know what code blocks are. One last thing I want to talk about in this chapter is block level scope with variables. And by the word scope, I mean the area in which a variable value is relevant. So I already have this if statement right here. What I'm also going to do is create a variable. So I'm going to say let age equal to 30. Now then, if I define a variable using let or const in the root of the document, meaning not inside any code block, it's in the root of the document up here, then that will have global scope. And that means it can be accessed anywhere in the file if I want to use it. So it could be accessed inside this code block. It could also be accessed outside this code block. So let's just down here, console.log outside code block, just to let us know where this is. And then we're going to output age. Okay. And then we're also going to do the same thing, but we're going to do that inside the code block. So let's paste this inside here. And I'm going to say inside first code block and output the age there as well. So I'm just showing you this to demonstrate that we can access this variable, which has global scope, outside of the code block and also inside anywhere in the file because it has that global scope. So if I save it, we can see that we get that value in both cases. Okay, so that is global scope. Now, I can also change that variable inside here. So I could say now age is equal to 40 inside here. And that is going to access this global scope variable, change it to 40, and then output it here and here. So if I save it and preview, we can see that now it's 40 in both cases because we change it here first before we output it anywhere. Now then, what if I try to redefine age outside here? So if I say let age equal to 50. So I'm trying to redefine the variable again. I'm not just trying to overwrite it by saying age is equal to 50 now. I'm trying to completely redefine it by saying let age equal 50. Now, it's not going to let me do this. It's already been declared. And I can't do this because it's in the same scope. Okay? Now then, what if inside the code block I try to say let age equal 40? Well, what's going to happen there because I'm trying to redefine it again? Well, if I save it, let's preview the results. So we see inside the first code block, we get 40 for the age, and outside the code block, 30. So firstly, most importantly, we don't get an error. So we are allowed to do this. We're allowed to redefine the variable inside a code block, even though it's got the same name. Now, secondly, it's only creating age equal 40 inside this code block right here. Outside, age still refers to this, but inside, age refers to this. So what this is doing here is creating a local scope for this variable age inside this code block. If I just use age, then it refers to the global variable that's already been defined. But if I redefine it, what it does is recreate this variable, but it gives it local scope. Now, we can only access this version of age inside this code block. So let me try something else. I'm going to say let name equal to Sean. And what I'm going to do is output age and name here and age and name here. Let's see what happens. Save it and preview. And we see Sean here, but we don't see it outside the code block. And that's again because we're creating this variable inside the code block. We're giving it a local scope, meaning the scope of this variable is only valid inside this code block because we define it inside here. We're not defining it outside here with root level scope or global scope. So if we define something in a code block, it only has that scope and we can't access it outside of that code block. Does that make sense? Okay, this is also true for nested code blocks. And by that I mean if we had some other if check in here, so we'll just say if true so that it does fire. This is a nested code block. We have a code block nested in another block. Now inside this code block, what if I try to access age? Let me console.log first of all, and we'll say inside second code block, and spell this correctly, will output age. So what value do you think we're going to get here? Because we've defined it here, but we've also defined it here locally. If we save it and preview, we can see inside the second code block, we get 40, which is the value we defined in here. So what it's doing is taking the most recently defined value. So the value whose scope is most immediate outside of this code block. If this wasn't here, then it would take this value. I can demo that, save it, and we can see 30. But because we've redefined it inside this code block, and this code block right here is all of here, this is the scope of this variable now, all of this code block, including this stuff in here, it means that inside this code block, when we use age, it gets this value. Okay then, so what if I try to say then, let age equal to 50 inside this code block? Well, again, we're creating a new variable with local scope, but this scope is only valid inside here. So we're not overwriting this one right here, we're creating a new local one with local scope inside just this code block. So if I save it now and preview, then we should see 50 inside the second code block, okay? Now, so far we've just used let, but the same would be true if we used const. So let me just now change all of these to const. I'm just going to place my cursor in front of all of those and change them all to const and save it. And we're going to see exactly the same results. Obviously, we can't change constants, so we couldn't later on say something like age is now equal to 35, because once we define a constant, we can't change them. But the same rules of scope apply to const as they do to let variables. So this idea of block scope is one of the main advantages of using let and const instead of the older var keyword, because when we make a variable using var, it ignores block scope. So we could have a variable defined, down here. Let's just say var test is equal to hello, and we can then access that outside down here. So we could say test, and that would work. So even though it's defined inside this code block, it's not given block scope, whereas these things are once we create them, okay? So that is one of the main advantages of using let and const, because a lot of the time it's useful to declare a variable that is only used inside a code block. It's much better to use let and const instead of var where possible. So this idea of block scope might seem strange at first, and even probably could go straight over your head, but do watch the video a couple of times over if you're struggling, just to understand at least the basics of block scope, because it will definitely benefit you going forward.